Next, we're going to talk about the empty set. The empty set, or sometimes called the null set, is a set that contains no elements. And it is written either like the braces with nothing inside, which clearly is the empty set because there's nothing in there, or this circle with a line through it, which means empty set. It does not mean zero. It means the empty set or null set. So some examples are, in set builder notation, the set of all x such that x is a number less than 3 but also greater than 11. Well, there's no numbers that are less than 3 and also greater than 11 at the same time, so this would be an empty set. In word description method, the set of all triangles with 4 sides. Well, the definition of a triangle is that it has 3 sides, so there are no triangles that have 4 sides, or just the empty set, and that would be roster notation. Note, if there is a 0 inside your set, this is not an empty set. The set of 0 is the set that contains the number 0, and therefore not empty. Therefore 0 is not an empty set. 0 is a number. Whereas 0 with the line through it, this doesn't actually mean 0 with a line through it. That actually means null set. It means a set with nothing in it. A lot of people get those two things confused. 0 is a number and therefore it is an element. Okay, the 0 with a line in it means empty set. Now we have a new notation we need to talk about in set membership. The symbol, and it's like a C kind of with a line in the middle, almost like an E, but it's just like a clean C with a line in it, is used to show that an element is a member of the set. For example, 4 is an element of the set of all x such that x is an even number. Is 4 an even number? Yes. So therefore 4 is an element of. Does it mean it's all of the elements? No, this isn't roster notation. This just means that 4 is one element of. Now we can also use this symbol. It's very similar. It's the symbol with an E in it and then a slash through it, is used to show that an element is not a member of the set. For example, 4 is not an element of the set of all x such that x is an odd number. 4 is not odd, therefore 4 does not belong in that set. So let's do some true false. Is 4 an element of the set 1, 2, 3, 14? Well, each one of these is a natural number from 1 to 14, and 12 is, so this is true. True or false? 11 is not an element of 1, 2, 3, all the way to 9. Well, 11 is greater than 9 and it stops at 9, so this is also true. Okay, now we have the set of 3 is an element of the set 3 and 4. This is false. Right here, you cannot have a set be an element of another set, okay? If it said 3 is an element, so this, let me say that this is false right here, okay? If it said 3 is an element of the set of 3 and 4, this is true. But if it's the set of 3 is an element of the set of 3 and 4, this is false. Okay? You can't have a set being an element of another set. That doesn't make any sense. Okay? Next, I want you to actually fill in yourself. So 8. Is 8 an element of 1 through 10 or not? Well, it looks like it is because it belongs in between 1 and 10 and it's a whole number. How about the next one? R is an element of A, B, C, and Z. Is that true? No. R is not an element, so we're going to put the element symbol and then a slash through it. All right, Monday. Does that belong in the set X such that X is a day of the week? Well, yeah, Monday is a day of the week, so I can say it is an element of. Next, we're going to be talking about sets using natural numbers. Remember that natural numbers are the counting numbers. We talked a little bit about this on the previous page. The counting numbers are 1, 2, 3, 4, 5. Things that you might be able to count on your finger. Even if it gets up really, really high, it's still part of that. So if I have the set of all x such that x is a natural number and less than 10. So in roster notation, I'm talking about the counting numbers that are less than 10. So the counting number starts at 1, 2, 3, ... 7, 8, 9. Do I get to include 10? Well, no, it has to be less than 10, so I have to stop at 9. So this would be the roster notation for our first set here. Next one, I have 50, 51, 52, ... all the way up to 70. So the way I would build that is I would start with a set of x such that x is an element of the natural numbers, which is a set. And usually we write that with an extra line there. If you're typing it, it can just be bold, but if you're not typing it, you put an extra line there to represent that you're talking about the set of all natural numbers. And it has to be equal to 50 or greater, and also less than or equal to 70. Next, we're going to talk about cardinality. The cardinality of a number of a set A is the number of distinct elements. That means unique, okay? It means they can't repeat. In a set written, and we have n of the set A, pronounced n of A. So kind of like function notation, we have f of x. This is n of A. So what is the cardinal number of the following sets? Well, sometimes you have to actually think about what it is. So let's put this in roster notation. We have 1, 2, 3, 4, all the natural numbers, the set of all x such that x is a natural number and x is less than 10. So that's all of the counting numbers all the way up to 9. So n of p, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So therefore, the cardinality, or n of p, is equal to 9. How about q? Q is the set of all elements x such that x is a day of the week. So what is the cardinality of q? Well, how many days of the week are there? Well, there's 7, and I don't even need to write that out. I know that there's 7 days of the week. R is the set of A, B, C, and Z. So what's the cardinality of R? N of R is equal to 1, 2, 3, 4. I'm just counting how many elements there are. So you could do it in roster notation, word description notation, or set builder notation. You can still find the cardinality of the set.